Hello and welcome to my clip on how to do mole calculations. I'm going to take you through a simple technique we use to do this, and I'm also going to include how to choose which equation to use, in addition how to choose which units you need and how to convert them. So what "Did Molly eat my apple" really stands for is data moles equation moles answer. So what I've done is I've written next to data moles equation moles answer what each stage actually stands for. And you'll notice at the bottom, where I'm talking about how to work the answer out, I've made mention of the mole equation and also units. So that's the next thing I'm going to take you through, how to choose which mole equation to use, and also how to choose how to convert the units. So you can see we've got two equations so far. The two that you've learned at this point in November of your first term would have been moles equals mass over molar mass and N equals V times C. There's also a third one that you won't have come across yet that won't be dealt with until after reading week, which is how to work out moles using gas volumes. I'm going to include this one because if you come back to this video later on in the year, by that time you'll have been taught it. It can be found in the book, and I'm just going to put a reference of the page number to go and look at it if you wish. So the third equation, V equals 24N, can be found on page 28 of the textbook. If you want to go and look it up, if you haven't covered it in class yet, that's okay. It's not going to come up in your tracking test, but it might be worth just having a look at for a little bit of reading ahead. So the two main ones I'm going to focus on are the one in red and the one in blue. So moles equals mass over molar mass and N equals V times C. So up in the top right hand corner I'm going to put a couple of bits and pieces on how to convert units, and then you've got a page you can copy. If you're going to do any boot camping with this video, I suggest you boot camp this particular page when I'm finished with it. That's the page to remember off by heart. The pages that are coming up after this are just going to be worked examples. This page that you're looking at right now, once I put the units up in the top right hand corner, that's the one to boot camp. So copy it down and then do look, cover, write, check, repeat, until you can actually put this page down on paper as it is exactly from memory. No mistakes at all. Okay, 2 seconds and I'll have the units technique up in the top right hand corner for you. So this is the time to pause and to copy this page down and to boot camp it. So in other words, you copy it, then you grab another piece of paper and you look at the first piece of paper that has the copied page on it. Then you cover the copied page and you try and write it from memory. You check by looking at your copied page, their second copy, against the first copy that you copied off this screen. If there's any mistakes, you have to go back to start again and keep doing that over and over again until you can reproduce it 5 or 10 times off by heart with 0 mistakes and 0 cheating. That's how you will remember how to do this, and then you can go on to try some work examples. So it's your call. I think that's the best thing to do at this point. If you're feeling confident and you've done some practice questions in your homework, for example, then please just keep playing, go on ahead, and we'll do a couple of worked examples right now. So if you're looking at this one, I'm assuming that you've either boot camped the previous screen or you already know it and you're ready to start applying it. So we're going to look at data first. You can see that we've got some data here, 50 centimeters cubed of 2.0 moles per decimeter cubed HCl. So that allows us to work out moles using N equals V times C. So let's put that in. So you can see a couple of things I've done here. Instead of just putting N equals V times C, I've put N and then HCl. The reason I've done that is because they want me to work out the number of moles of HCl, so N with an HCl next to it means the number of moles of HCl. You'll also notice that I've taken the 50 centimeters cubed and I've divided it by 1,000. The reason I've got to do that is because the concentration that I'm multiplying it by is in moles per decimeter cubed. So I have to make sure that I convert centimeter cubed values into decimeters cubed so they can be put into N equals V times C. A third thing, which isn't essential but it's a nice touch in an exam, is to underline your answer. The reason you underline your answer is so that the person looking at your paper knows exactly which thing you want them to mark. So the rest of it will be method marks if it's applicable. Here it's not because it's only 1 mark. So the thing you want to earn your 1 mark for you is 0.10 moles of HCl. So the next thing to do is to calculate the mass of calcium that she used. The key thing in this bit is mass, which means grams, which means moles equals mass over mR. So I'm being careful in selecting the correct equation. So let's have a look at this one. So looking at it, I don't actually have any data, do I? I have nothing to tell me the mass of the calcium. But wait, remember what we said before? We said to use the equation. So this is where I can use the equation. So what I'm going to do is I'm going to pop the number of moles of each thing above it in the equation so you can see what I mean by the mole ratio that I talked about in the previous screen. So you can see what I've done is above the equation I've put in 1 mole, 2 moles, 1 mole and 1 mole, which tells me that if I've worked out that there are 0.1 moles of HCl, I can now work out how many moles of calcium I'm working with. Now clearly I'll have a periodic table as well, so I can use the periodic table to work out moles from mass from moles and mR, or molar mass. So looking at the ratio of calcium to hydrochloric acid, it's a 1:2 ratio. So again I'm making sure to lay out my calculation carefully. So let's look at how this might pan out. You definitely get 1 mark for the correct answer there. You get 1 mark for working out the fact that there's a calcium to HCl mole ratio of 1:2 using the equation, and you get your 3rd mark for working out the correct grams of calcium. You could probably get away with 2.00 grams of calcium here, but you'll notice I used 40.1 straight out of the OCR periodic table. I did not round it down to 40, I left it exactly as it is, so please make sure when you're doing this kind of calculation you just lift the value out of the box in the periodic table for atomic mass as it is. Don't round it down or up or try and do anything clever with it mathematically, because you will lose a mark for doing that. So let's now try an example that involves using the gas equation, the one you possibly might not have covered in class yet. But it's no harm to have a look ahead every now and then, and reading week is as good a time as any. If you're looking at this later on in the year, then it's a good revision for you. So I'm going to make a new screen now with another calculation, another question, but this time it will also ask you about gas volumes that requires you to use V equals 24N. So this is quite a nice one because it requires us to use all 3 of the equations. So you need to have your bootcamped page with your different equations on there. You need to have your moles equals mass over mR equation. You need to have your V equals 24,000 N equation, and you also need to have N equals V times C. So the first one says, show that 8.0 times 10 to the minus 4 moles of barium were added to the water. So if you look at the first sentence at the top, the only data that's to do with barium is given in grams. This is automatically now moles equals mass over mR. Okay, so what you do is you take the grams that you're given, 0.11, and you go and look up the atomic mass for barium, relative atomic mass, and the relative atomic mass for barium on the periodic table is 137.3. So let's do that calculation in a sec here. So you can see what I've done. I've written in the number of moles of barium is the mass over the molar mass of barium, stating quite clearly molar mass of barium. So the examiner knows that the 137.3 that I've put in is actually the one I've gone and looked up, which gives me 8.0 times 10 to the minus 4, like the question asked me to. So the next one is calculate the volume of hydrogen in centimetres cubed. Now they've specifically said in centimetres cubed, so this is going to need the V equals 24,000 n as opposed to V equals 24n. So what I did is I used, like I said, volume equals 24,000 n, and I got n from the equation. So it's data, moles, equation, moles, answer. The equation tells me that there is 1 mole of hydrogen gas for every mole of barium, which for your convenience I've just popped up above the equation. So now I know there's a 1-to-1 mole ratio. It means I can automatically assume that the number of moles of hydrogen is also going to be 8.0 times 10 to the minus 4. So because A, they wanted me to do it in centimetres cubed, and B, I know the 1-to-1 mole ratio, I simply multiply 24,000 times 8 times 10 to the minus 4, which gives me 19.2 centimetres cubed of hydrogen. So what I've done this time is I've used n equals V times C, because it's a concentration calculation. I've had to rearrange it to say C equals N over V, because they want me to work out the concentration, not the moles. I know that from the equation you have a 1-to-1 mole ratio as well of barium to barium hydroxide. So barium hydroxide is also 8.0 times 10 to the minus 4 moles, which I've just adjusted up on the equation for you to follow. So I take the volume as 100 centimetres cubed of water. Don't worry about the hydrogen that's given off. It's negligible in terms of the volume of water that's been it came from. So what you do now is you take your 100 and you divide it by 1,000 to convert it into decimeters cubed, because your volume in N equals V times C has to be in decimeters cubed. So that gives us 0.008, or in standard form 8.0 times 10 to the minus 3. So we get a mark for the correct answer up here, but that mark is for actually proving that it's 8.0 times 10 to the minus 4, not necessarily the final answer, because they gave you the final answer. They gave you 8.0 times 10 to the minus 4 here. So you don't have to worry about that getting you a mark. It's the calculation that leads you there that they want to see. 19.2 centimetres cubed gets you a mark. 8.0 times 10 to the minus 3, or 0.008 gets a mark. Okay, the thing to do now is to find some other worked examples and apply your boot camped summary sheet and practice them so that you can not only remember what to do, but apply it as well in a variety of settings. Good luck, and contact us at BASVIC, any of your teachers, or myself, Jason, if you wish, and we can help you out. Thanks for listening.